No one told you life was gonna be this way. Your job's a joke you broke, your love life's the old way. It's like you're always stuck in second gear. When it hasn't been your day, your week, your month, or even your year. But I'll be there for you. Your race starts to go. I'll be there for you. I'll be there for you.
Hey guys, if you don't know my name already, my name is Brandon, and I love chemistry almost as how much I love Christmas. You know what's another great way to learn about science? Baking. And physical and chemical changes are known for what they are. A mixture is anything made by combining two or more different things. A mixture is a big factor in physical and chemical changes. Physical changes occur all around you. Sometimes you don't know these changes are there. For example, you know that one time when you leave ice in your water and you leave it sitting, then when you come back, the ice is gone? This happens because the ice is melted. The water molecules that are once in the ice are now being represented into a different form. This is an example of a physical change. On a cold Christmas night, you might just throw firewood into the fireplace. Then you might throw a couple more wood in the fireplace to keep the fire going. This is an example of a chemical reaction due to the fact that how the wood is simply burning. Or if you're on Santa's naughty list and you don't want to be seen on it, you know, you can simply just burn it. This is also a chemical change, but this leads us into our next topic.
Conservation of mass. In the naughty list, the matter is not being created or destroyed, only its form is being changed. It seems as if the mass shrinks as the paper burns. However, what's really happening is the paper is changing its form to ash, to carbon dioxide, and to water vapor. Let's think of something else. So, for example, think of your presents. The presents here are your subscripts. And the numbers here are your coefficients. On this side here is the product, and here is the reactants. And the coefficients tell you the moles of a substance in a chemical reaction. So as you can see, there are two or more chemical substances being combined to form a more complex product. This would be considered a synthesis reaction. Now if we were to do the opposite and rewrite it like this, then this would be considered a decomposition reaction. There are many different types of chemical reactions. The list goes on. For instance, single replacement reaction, which is when one reactant is being exchanged with one ion, and double replacement reaction, which is when two reactants are being exchanged for an ion. But this can oftentimes get confused with precipitation reaction and neutralization reaction. And last but certainly not least is combustion reaction, which is when a compound and oxidant are reacted to in order to produce a new product along with heat.
So what is chemical kinetics? Basically, chemical kinetics is how fast a change occurs in a chemical reaction, or also known as the reaction rate. A chemical reaction occurs when molecules collide and react with each other. However, there are such things as effective and ineffective reactions. An ineffective reaction is when molecules collide and don't change the end results of the products made by the reactants. An effective reaction occurs when molecules collide and do change the end products of the molecules made by the reactants. When there's a minimum amount of energy needed for molecules to collide and react, it's often called activation energy. However, a catalyst can speed up the process of a chemical reaction without actually entering it. So the more chemical reactions that occur, the more reaction sites there are. Reaction rates depend on three things: concentration, temperature, and the surface area. Moles are chemical units that can be measured by molarity and molality. So molarity is the number of moles of solute per liter of solution, whereas molality is the number of moles of solute per kilogram of solvent.
This specific ornament isn't one you'd find in stores. Its generic formula is AX, A representing the central atom and X representing the one bonded atom. Its electron geometry and molecular shape is linear because it forms a line, and it has a degree of 180. The repulsion between the electron pairs increases along with the electronegativity of the central atom. Well, now that we're talking about theories, let's get on to the quantum theory.
So I'm going to teach you about quantum numbers. Each quantum number gets a letter, so it can be easy to understand. Printable quantum numbers range from 1 to 7, and angular momentum numbers go by L, like little L's. Its value goes from 0 to n-1. Magnetic quantum numbers is a lowercase m with a capital L. Under it goes L to -L.
Have you ever been forced to share a Christmas gift with a sibling? Well, it's like sharing an electron and a chemical bond.
There is also times where the electron and nuclei repel from each other. This is called a covalent bond.
Back to what I was saying, ionic bonds have a long-lasting attraction between atoms, ions, and molecules, which then enables them to form a chemical compound. This here is an reciprocal, which aka is the simplest form.
Do you enjoy bonding with your family or friends? Covalent bonding has bonding in its name. Bonding in pairs like length, energy, and order. But some, on the other hand, will rather be alone, known as lone pairs. That they don't want to be shared, unlike your Christmas gifts. In covalent bonds, the intramolecular forces as any other forces that holds together the atoms which are making up a molecule or compound, usually stronger than intermolecular forces which are present between the atoms or molecules which are not bonded.